My name is Malek. I'm a research scientist and representative for the Nushoor Institute. And behind me is a greenhouse that we have been working on with the end goal of assisting refugee communities that want to rebuild, particularly in the area of agriculture and food sovereignty. Greenhouses are well known to be allow for extended growing seasons and increase crop production. And so we wanted to build one ourselves, not only so that we can, begin to gain sovereignty over our own food supply, but also so that we can help and assist our contacts all around the world who are struggling in these areas to build similar systems using the materials available in their areas, in their localities. So I just wanted to make this video to show the kind of work that we've been doing, and inshallah to allow people to better understand the principles at play in these greenhouses, and to see that they're really quite simple, and inshallah to inspire others to pursue a similar path. So I guess to start, the main aspect of this greenhouse is the hoop-shaped structure. This hoop-shaped structure can be attained through many different methods and principles, and it's based on some well-established videos. Typically, people will use cattle panel, which is basically a certain type of steel fence that has a very thick relatively thick gauge diameter, approximately 5 to 6 millimeters. However, this cattle panel can be somewhat expensive and can be difficult to obtain in certain parts of the world. So as a result, we tried to produce this hoop shape using a different material, albeit that operates under similar principles and is made of a similar element, in this case steel. In our case, we used 12.5 gauge steel wire fence that has been welded together. We bought these at a hardware store for about $35 for a big roll. Our system is 6 by 8 feet, which comes out to about 48 feet squared, which is about 5 square meters. And we selected the steel wire fence accordingly. So the hoop shape is also obtained through a very very strong wooden frame. So in theory, this whole frame could be built with wood. However, we wanted to leverage the steel wire fence because this fence material forms a hoop shape naturally when you tie it down on both ends. It wants to form this hoop shape naturally, and so we wanted to leverage this. However, it doesn't form hoop shape, very stiff hoop shape. And so to help provide stiffness to the structure, what we did was we built a wood frame. And this is very common in other DIY projects, hoop greenhouses. You'll see them build a wood frame. And so the wood frame here comprises of a bottom base, which in our case we were trying to use scrap materials and be as resourceful as possible in our own build. So we used wooden fence material for the base, and then we also used some 2x4s that we had left over to build out the front outer door frame. And then in the back as well, we built a similar frame out of 2x4s. And so these 2x4s combined with the fence at the base provides a pretty good, solid skeleton, if you will, that we can then wrap the steel wire fence, attach the steel wire fence to, wrap it around. And then there's also a key piece of the wood frame, which is there's a 2x4 that runs along the top center between the two, the front and the back. And this 2x4 provides just a lot of stability to the whole structure and allows for the steel wire fence to be attached to, and it again gives it just a lot of stability. There is some movements in the structure, but it's very strong overall, and quite stiff. It's not going anywhere. So this is kind of one of the main principles is the hoop shape. Now, other principles involved in the hoop greenhouse is you need your system to be able to be wind resistant as well as flood resistant. So you want it to be weatherproof. This is a pretty important principle that many other videos go into detail about. But the general idea is that you want it to be fixed to the ground. And there are many different ways you can do this. The way that we did it was we drove 4 iron rebars into the ground about 2 feet, and we put these at the 4 corners of the bottom frame. And again, this is just to provide a lot of support and a lot of stiffness to the base structure to prevent, so that when wind comes around, it doesn't get just blown away. It just gives it a lot of stability at the base. And so we added those rebars. We used a lot of different low-tech methods to fasten things together. We're trying to replicate the conditions in places like Gaza, places like Sudan, places like Bangladesh, refugee camps where they don't have, Home Depot. They can just go and get some special type of fastener for that. They have to be a little bit more creative with what they have already around them. And so this is really one of our main focuses. So we used certain types of knots, you know, uh, taut line knots that can help with keeping things in tension and keeping things pulled together. We've used certain hitches, gem hitch knots to help act as zip ties, DIY low-tech zip ties that can bind things together tightly and securely. And so that's how we secured a lot of the base structure here to these rebars in the corner. And again, that all of this is just to keep, good structural stability. We also used cinder blocks on the inside, and these cinder blocks serve two purposes, or I guess maybe three. The first is, to act as a shelving. So we have wooden fence posts. Again, all this is salvage materials that we run across these cinder blocks, and this is to make makeshift shelving. The second, functionality of the cinder blocks is to provide weight to the structure. The weight, again, also just helps keep everything down. And then when we tie these and fasten these to the rebars in the corner, it just gives it a whole lot of stability and, helps to, again, secure those rebars to the ground and keep the base of the structure to have high structural integrity. And then, I guess, the third reason is, we needed some way to have this, to attach the steel wire frame to. And so the cinder blocks, we've stacked two on top of each other, and then we have a 2x4 running across them. And this is, this is all just to provide an anchor point for the steel wire fence. So when you combine all these factors, it makes it a good choice to use the cinder blocks. Other alternatives could be to use lumber, but cinder blocks are made of concrete, readily available, especially in disaster context, or other types of brick type materials. So we thought it would be good to use in this design. These are kind of the main structural principles. The other important principle, obviously, that you can see is the tarp. The tarp in a greenhouse basically just ensures that all the light that comes in, radiation that comes in, gets trapped. Plastic has an interesting property where it allows light through, but it does not allow infrared radiation out. So infrared radiation is, high wave, large wavelength radiation, but it oftentimes is what transmits heat. And so if it's trapping the light and not allowing infrared radiation to escape, this is called the greenhouse effect, and this is obviously related to climate change as well. But this is what allows the greenhouse to maintain a high heat environment, and that high heat is great for maintaining high humidity and as well as extending the growing season of plants into winter and colder months as well. And of course, it protects the plants from wind and other snow and other weather that might make it otherwise challenging to grow or kill crops. So that's the tarp. This is a very cheap material. Can be bought on Amazon or Temu or other platforms for very cheap. We also rely heavily on a brother from Gaza named Taysir, who is brilliant. He's an innovator. He's a builder. He's a father. And he's still somehow able to find time to build all kinds of systems. He's built washing machines. He's built a water heater. He's built rainwater collection system. He's built, he's managed his own like a mini farm on his property. He's built water tanks. He's built, all kinds of devices to support the livelihood of his family and to allow them to just continue, to survive amidst the genocide. And so he's also built shelters, DIY hoop shelters, so similar to this in principle and many principles. And we actually took a lot from his methods to build this system as well. But yeah, one thing he uses a lot is a staple gun, and we found that the staple gun is actually an excellent tool for this project and really for all kinds of projects, as it allows for very quick and secure fastening between objects. So we use a staple gun. We must have used a couple hundred staples. Staples are very cheap, thankfully, so it's not a huge cost. But yeah, we used a lot of staples all over the design, just to secure the tarp to the frame, get everything as taut as we could. Of course, it's not perfect, but it's pretty taut. And this prevents water from getting, pulling up and causing rips in the tarp, things like that. And we're also in the process of using this greenhouse to test out rainwater harvesting using a gutter system, DIY gutter system on the sides. And this will just allow, the greenhouse, water's going to, drop on it from the rain. We want to be able to take advantage of that if possible. And so we have this gutter system that we're going to test that will direct water into a pond, and that pond will, can be further purified or boiled and used for cleaning, for, farming purposes. It can be used, obviously, for drinking if it's boiled tea and things like that. So, or even for cooking as well, boiling food. So, there are a few other, minor details. For example, regarding the tarp, you don't want the tarp to get cut by the steel welded wire at the edges. And typically, people in other videos will use foam insulation. However, the problem with foam insulation is might not be available everywhere in the world, and of course, it costs money to make and produce, and requires a certain type of manufacturing process, all those kinds of things. So an alternative in which we were using in this design is just plastic, scrap plastic that we had left over from other projects, and all we did was wrap the plastic around the edges of the steel welded wire fence, and use some zip ties to secure it in place. And we found that this works pretty well to protect the tarp from getting cut by the steel fence. Some other optional, features that many people will implement in their greenhouse, especially in this kind of hoop greenhouses, DIY hoop greenhouses, is a door, a front door, and a back window. So because it gets so hot in the greenhouses, you do need a back window, at least in some capacity, to vent heat. Especially in the summer months, it gets extremely hot in the greenhouses, and some people have automatic vent opening systems. These need some work in order to be applied in humanitarian contexts or to be developed for humanitarian contexts. But in any case, it's nice to have a back window just to allow heat to escape from the greenhouse. And in our case, we made these out of 1x2 lumber, and again, very simple frame. If you just measured it out, and then we used some rubber hinges to some hinges made from rubber hose. This is just an appropriate technology approach. If hinges are difficult or expensive to obtain, this is an option that we have found works fine, and we've had no issues with this system in terms of allowing the window to open and close. We included a little locking mechanism to allow the door to be open and closed, and it can be. We have like a little doorknob here as well to allow the door to be opened. So it's quite simple in principle, but it gets the job done. And again, this is optional. Some people don't even make doors just because it adds extra steps. Sometimes people just have a tarp that, a curtain that they can open and close and get in and out. But we found the doors has been a nice touch. And that's some details about that. So this is the greenhouse. I think in summary, I would say it cost no more than $50 in terms of material that I had to buy. Everything else I used on hand. But I would say if I had to include the price of lumber, if I had to include the price of the cinder blocks, the price of the fasteners, staple gun, or the staples, and a nylon string that was used to tie things together, I would say those components probably come out to no more than another, an additional $50 to $100. So I would say, we were able to build this greenhouse with less than $150. It did take some labor. It took about 4 days. This is my first time doing it though, and I think if I did it again, I think I could get it done in 2 or 3 days, to be honest. And overall, I was pretty happy with the design, and want to transfer these principles, transfer this knowledge elsewhere, and help others rebuild and gain sovereignty over such critical resources like food and water that we often take for granted. So I think paramount for us to use our privilege, use our abilities to help those in need. And we're working with group Veranda from Malaysia, who's trying to build a greenhouse, rebuild their greenhouse that was destroyed by flooding, and we're trying to use these principles to help them, build their greenhouse stronger, make it last for years, and that it can serve their community and give them a source of food that may help them make their life easier, and allow them to rebuild from the ground up rather than through outside intervention. And so this is our intention, inshallah. We hope that this video was informative and that it may help others to build the greenhouses and gain sovereignty over their own food. And thank you for your time. Jazakallah khair.